Good morning, everybody. Today is the last day of our workshop. Hopefully, the first 2 days have been something that is useful to you. Yeah. In any case, I've already sent out the recording for first 2 days to your parents. So if you need to relook at the slides again, feel free to do so. And feel free to clarify with me if there are any issues. Okay, so what are we going to cover today? Quite a bit. Okay, so we are going to review what we have done yesterday's content. And we're going to discuss a little about how to finish the paper in time and with accuracy. Okay. Thirdly, we're also going to cover a review of what we have done in day 1 and day 2. And I'll be asking you, with regards to certain questions, what concept is being tested? We'll go for a break after that. And following that, half an hour of handling out of place questions. That means questions that when you read, right, you somehow do not know where it kind of fits in, what kind of concept, is kind of hazy. So we will spend some time to look at that before closing. Yeah. Any questions before we start? No? Morning, Police. Okay.
Morning.
Good morning. So we'll move on. Okay, so just a quick recap of what we have done yesterday before we move on to this. Anyone can remember what we've done yesterday? Give me one thing that you have remembered from yesterday. We did talk about growth mindset, yes, if you can remember. Yeah, growth mindset is about believing that the brain is able to grow when we don't limit ourselves. Sorry?
Units and values.
Yes, units and values. Yeah, that's what you learned as well. We took up quite a big amount of time on that. What else other than units and values? There's also constant difference, yeah, that we spend some time learning. Yeah, and again, we reinforce the concept of the idea of finding keywords to answering the questions. Yeah, so if you can remember yesterday, Kaiten did mention that sometimes it's very hard for us to identify what the question is trying to ask. We always go back to the basics. What are certain words that the setter has put in to give you clues to handle it? Yeah, okay. And today we are going to move on to another aspect of how to ace PSLE exam. So if you can see in the screen here, it's actually the exam format. Okay, so I'm not so sure whether you remember or does your teacher, has your teacher gone through with you the format? Are you well versed with it? Not well versed. Okay, Ella, first time seeing it? Okay, how about the rest? Is it first time looking at this? No, Alexa has seen it before. Collis and Gwen?
First time.
I never see before, but I know
You know what it comprises of. All right, okay. It's good that we have it here today. So let's do a simple breakdown based on what we have here. You can see that from paper 1, I think all of us know there's a booklet A and a booklet B, right? Okay, and booklet A covers multiple choice questions. The first 10 questions are actually 1 mark each. What does it mean by 1 mark each? Does it mean that it's the harder kind of questions or the easier kind? What do you think?
Easier.
Yes, most likely it's the easier kind of questions. Yeah, it's the knowledge kind of question whereby once you see, you do not need to take very long to get to the answer. So in terms of impression wise, you need to know that probably for the first 10 questions, where it's 1 mark each, you might not want to take too much time to do them. Okay, now for the next 5 questions, questions 11 to 15 is actually 2 marks each. You will realize that the difficulty level is higher than the first 10 questions. So probably in terms of planning of time, you might want to give a bit more time to that. Okay, and do expect yourself to face some challenges when answering those kind of questions. read or even double read, triple read if you find that, hey, it's like so easy, you know, how can it be 2 mark kind of question? Yeah, maybe sometimes there might be a trick in there. Okay, and after that, moving on to booklet B, there are also 2 types of question. Under short answer, first 5 questions is 1 mark each. So here you can guess difficulty level would be not as high. Whereas the next 10 questions, it's 2 marks each. So this is probably the one that is slightly more challenging. And this first paper takes up 1 hour. So let's talk about it. Maybe you can, you could feel free to unmute yourself. Let's just spend some time to talk about how you think you might want to break down this 1 hour to do this paper. See, when we break down, we want to consider the amount of time taken for booklet A, amount of time taken for booklet B, and we also want to take into consideration something else, not mentioned here, time for checking. Okay, so how are we going to split this 60 minutes up into these 3 portions? Anyone has thought about it? I would like to share any thoughts? Do you allocate time for checking? Or you only check when there's some time? Come, let's hear from you. Anyone? It's okay if
I check if there's like remaining time, because sometimes I
Okay.
might need a longer time to finish the question.
Okay, so there are certain occasions where you don't check because you realize that time is just enough. Okay. How about the rest? There's no right or wrong. Ella, any thoughts? No thoughts. Okay. Gwen or Collis, do you allocate time for checking?
I just see if got time then check.
Okay. Same for Gwen? Or just see, okay. So if, wow, okay, interesting. Yeah. So if you just see, right, just see cannot be just see, because let's say if multiple choice, there are certain questions you do not know how to do, then are you going to skip certain questions to move on to booklet B, or are you going to like get stuck at booklet A and then everything else not done?
I skip the question first if I take too long.
Okay, so consider skipping if you take too long. So this is one thing to take note of. I'll just put it down at the bottom first. So consider skipping questions if it takes too long. Takes too long to understand or takes too long to do?
To understand.
To understand. Okay, so if it takes too long to do, you will still persevere on to do. Okay. That means you are stuck, in other words. I would think that that would be wise as well. Okay. Perhaps I would like to suggest a very, very simple, simplistic way of breaking down the time so that when you have your watch, when you see the clock in class, you have an idea of where in your paper you are at least for paper 1. Okay, so if you were to look at 60 minutes being, and you want to split it into booklet A, booklet B, and hopefully if there is a bonus time, we could have checking. Why not? Let's consider putting down something like that. Okay, what I'm writing down is actually not cast in stone. Of course, you can modify as you go along. Just a simple guide. I was just thinking through. Okay, if we give 20 minutes to booklet A and 30 minutes to booklet B, seems like booklet A compared to B might be more manageable. I'm not sure what you think. Yeah, but I would think that the easier questions come from booklet A, especially those like question 1 to 5. You know, those marks that you can quickly grab, try to grab with as minimal time as possible. Okay, and booklet B, maybe after 15 questions of MCQ, you might be a bit tired, you know, then somehow there's no options given to you. You might want to allocate slightly more time. So I put down 30 minutes. and 10 minutes is just there to check if there is time. You see, the thing is, if you take 25 minutes for booklet A, then you have to take away 5 minutes from checking. Yeah, so this is how we can play around with the numbers. But I just thought that maybe it's good to mentally have a guide in terms of time so that you don't run out of time. Why is this guide important? Now, what I would advise usually to my students is that when you bring the watch, okay, to school and you set it in front of the table and you do the test, let's say you start off with booklet A first. Okay. Good morning, Edwards. Yeah. Let's say you start off with booklet A.
Hi, good morning.
And by the time half an hour has passed, okay, half an hour is already half of that 1 hour, right? So by the time half an hour has passed, let's say you're at question 10. Now, colleagues, can you tell me, do you think that is very good time management, or do you think you need to speed up already?
Speed up.
Yeah, I have to speed up already. So I think to have an idea of time and how fast the time has already passed will actually help you know whether you need to speed up or not. Let's say you do a paper and you finish booklet A in 15 minutes. Okay, so instead of the recommended 20 minutes, let's say you finish it in 15 minutes. Wow, this means that you can either have 5 minutes more for booklet B, or you could have 5 minutes more for checking. Hey, that would be a great bonus, because if we can discover careless mistakes, that would help you. Yeah, okay, so you might want to spend some time to think about how you want to divide your time. The 1 hour passes so fast, and sometimes if we don't think about it, it will just go and we won't get it back. Yeah, very soon teacher will say, okay, put down your stationery. Now, how about moving on to paper 2? Paper 2, of course, we know we have 17 questions. Yeah, I hope you're aware of that. And the first 5 questions are usually easier. They are just 2 marks each, followed by 12 questions of 3, 4, or 5 marks. And this, you can see, wow, that takes up 45% of the paper. That's a lot. So how do you think is a good way we can divide this 90 minutes? Doesn't seem so easy now, huh? Any idea?
Maybe the short answer can be 20 or 30 minutes.
20 or 30 minutes. Okay, so short answer means that we want to split up into the first portion, questions 1 to 5, is it? 20 to 30 minutes. Okay, so let's put 20 to 30 minutes first, and then we see how this plays out. I'm going to break down questions 6 to 17 into smaller parts, so it's manageable. Let me just put down question 6 to 10, question 11 to 14, question 15 to 17. Okay, 15 to 17, you're probably going to be very, very tired already. And of course, I put in some time for checking as well. Okay, so how do you think we could factor in the time? Now that, okay, Gwen suggested, maybe we take 20 minutes for 25 minutes from the 90 minutes for questions 1 to 5. Yeah, so 90 minutes, you take away 25 minutes. We have 65 minutes left. 65 minutes for this. Let's say if we have 15 minutes each. Do you think we might pass the time? Okay, this makes 60. Oh, just nice. Do you think this would work out? And do you typically spend about 15 minutes for questions 15 to 17, the really hard ones?
I still feel like for 15 to 17, I'll still take a bit more time.
A bit more time. Okay, so what would be a reasonable time? Let's just throw in our ideas so it gets us thinking after the session as well.
20.
20 minutes? Okay, maybe we will change this to 20 minutes. So if 20 minutes, right, then the 5 minutes got to be taken from somewhere. Okay, I'm taking this first part to be 30 minutes. Okay, so where do we take the 5 minutes away from? Could we take it from questions 1 to 5?
1 to 5.
Okay, so maybe this one we bring down to 25 minutes. Do you think this might work out? Do you think this might work out? Yes? Okay, maybe this might be a guide that you want to follow. And in any case, if you take more time for each of these small segments, you know that you have to eat into your checking time. Okay. Now,
You
where
can
do you
eat into the 1 to 5. 1 to 5 is too much time.
okay. So what would be a reasonable time that you could pace your 1 to 5?
15?
Okay, maybe we can put 15 to max 25 minutes. Okay, so once you check your watch, you realize, hey, 20 minutes up already. I'm still at question 3. You know you must you must move a little faster along the way. Yeah. Okay, maybe 15 minutes. So if it's 15 minutes, then you realize that, hey, you could plus 5 minutes here, you could plus 5 minutes here if time doesn't, it's not on your end. Okay, and the good thing is that while maybe some classmates who don't plan it this way, they have no time for checking, you have that time for checking, and that would be a plus. Okay, so checking would mean that you go back to questions that you have left blank. Checking means that you redo your calculation again. Checking means that you don't miss out questions. Sometimes questions are like A is very small blank, and then we might actually miss out that 1 mark. Yeah. So hopefully this short exercise does help you to think about how you plan your time with regards to the paper. So you don't see the paper as 1 hour, paper 1 anymore. You see it in chunks of 20 minutes, 30 minutes, 10 minutes. And for paper 2, now you don't see it as 90 minutes. You see how we can break it down further. So probably by the time you are at question 14, okay, slightly more than half the time has already passed. Yeah, okay. If I have question 10 and you have already passed half the time, you know you have to speed up. Yeah, so I hope you find this helpful. Any questions before we move on? Okay, in that case, we'll move on to the lesson. Let's take a review of what we have done in day 1 and day 2. See whether you can refresh your memory, reassess, and remember. So this segment, I hope to hear a little bit more from everyone. Yeah. Okay, let's jump in. So this question is taken from ACSJ prelims last year. After reading, can let me know what you think the concept they're testing about. The ratio of the number of marbles Ryan had to the number of marbles Audrey had at first was 2 to 7. So after Ryan bought another 20 marbles and Audrey gave away 80 marbles, the ratio of the number of marbles Ryan had to the number of marbles Audrey had became 1 to 3. How many marbles did Audrey have at first? What do you think?
The difference?
Difference. Any other thoughts? You realize that there's a before and there's an after, right? Okay, so maybe we look into the clues. What words are important? At first, yeah. 2 to 7. Okay. And then you realize that the word after was mentioned. So this is a before after kind of question. So in the after, what happened to Ryan's marbles? he bought another 20. So this is important. Audrey gave away 80 marbles. So there is a change in the proportion. And what happens to the ratio at the end? It changes as well. So 1 to 3 is important. Okay. So when there is a change in all these units and all, what concept comes to mind? This is about units and parts, units and values. Yeah. So the concept tested is actually units and parts. Okay, so let me show you how we come up with these units and parts. Where are the units? Let's start off with the beginning. In the beginning, we know that there are 2 people. So we have Ryan and we have Audrey. How many units do they both start out with? So we have 2 to 7, right? So Ryan starts out with 2U and Audrey starts out with 7U. Yeah. Okay. You can save the writing of the solution till later. I'll give you some time. Yeah, so you can listen first. So Ryan bought 20 marbles. Audrey gave away 80. What happens when Ryan buys 20 marbles? Do we plus a 20 or we minus a 20 to it?
Plus.
Yeah, so bought means plus, so plus 20. How about Audrey? Gave away. So minus 80. Okay, after this happens, what is the result of the proportion? It becomes 1 to 3. So at the end of the day, Ryan has got 1 part and Audrey ends up with 3 parts. Anyone not so sure about what I'm saying? Okay, now question. How come I put unit at one end and I put parts at the other end?
Because they are not equal.
Yes. The fact that I added a certain value to it doesn't give you units anymore, right? So I will classify under parts. Thanks, Collis. So we will have an equation 1 here and an equation 2 over here. Now, I'm not so sure whether you come across questions like that in school. So if you have, what is the suggestion given by your teacher? You realize that you have 2 unknowns. What are your unknowns here? You do not know what your unit is, and you do not know what your part is. So if we can make the number of parts become the same, we could equate the units together. So if you look at equation number 1, there is 1 part here. Could we change this into 3 parts, similar to equation 2? If we take 1 part multiplied by 3, and we do so for the rest of the terms here, we could get 3 parts. Okay, so I'm going to take the entire equation 1 and I multiply it by 3 over. So what this means is that instead of 2 units, I times 3, I will get 6 units. Instead of plus 20, I multiply by 3, I will get plus 60, and that gives me 3 parts. Okay, anyone lost so far? Okay, so at this point, let's focus on this and this. Could you see that on the right hand side, both indicate 3 parts? So they are actually equal to each other. If they are equal to each other, we could say that 7 units minus 80 is actually equals to 6 units plus 60. And from here, we should be able to find 1 unit. Let's draw a model to find out 1 unit. So how do we draw a model? Now let's see. 6 units plus 60 is probably easier for us to draw. So let's just put that down first. So I have 6 units and 60. This is equals to 7 units minus 80. Okay, what is 7 units minus 80? 7 units is way more than 6 units plus 60. So this whole thing is 7 units. And if I were to take away 80 from it, okay, if I were to take away 80 from it, I have 6 units and 60. So this is how I draw the model. How are we going to solve for 1 unit then? You realize that this portion here, 6 units and 60, is the same size as this. We could bring 6 unit and 60 down. Okay. And if we were to focus on just this portion, what can we tell from here? We could tell that 7 units is made up of 6 units plus 60 plus 80. Seven units split into 6 units and 1 unit. Yeah, because 7 can be written down like this in number bonds. So 1 unit must be 60 plus 80, which is 140. Now that we know what 1 unit is, let's come back to the question. How many marbles did Audrey have at first? So remember when we first started out, we wrote this as what Audrey had at first. So if 1 unit is 140, can we find what Audrey has at first? Anyone? How many units? 7, yeah? So 7 units. So that means 7 multiplied by 140. So 980. This is the answer. Okay, so I'll give you some time now to jot down the solutions. And give me a thumbs up when you are done. Okay, shall we move on to the next question? Let's take a look. This one is from Rosai School, last year's paper. Mark and Ali collected some newspapers for recycling. The ratio of the mass of the newspapers Mark collected to the mass of newspapers that Ali collected was 1:3. After the neighbors gave them 42 kg of newspapers each. That's a lot. The ratio became 2:3. How many kilograms of newspapers did both of them collect all together in the end? So what's the concept tested here? And what were the words that that came to mind before you decided?
One, two, three.
Okay, 1, 2, 3. There's 2 to 3 as well, right? So this one looks like a before after kind of question. What else is important in the question here?
$42 kg.
Just 42 kg?
Difference remain unchanged.
The difference remained unchanged. And what is key? Neighbors gave them 42 kg of newspapers each. I think the word each is important because it's not together, but each of them has 42 kg given. So the concept here is constant difference. So let's try to resolve this question. We have the before and the after. So since everything, the units are all given in ratio here, probably let's come up with the ratio before and after. And because it's constant difference, do we need to add a third column? Probably so, right? Yeah, that says difference. So we have Mark and Ali. And the last column will be difference. This will be before, and then for after, we have Mark and Ali again, and the difference. Okay, could anyone give me the first ratio?
1, 2, 3.
1 to 3.
1:3:2.
To 2. Okay, don't forget the difference. How about the second one?
2:3:2. No, 2:3.
It's 2, 1, right? Yeah. Okay, so if it's constant difference, we have to make one more step to make the difference become the same. Anyone?
Times 2.
Okay, we multiply the second ratio by 2, right, to get the difference to become 2 units. So it will become 4 to 6 to 2. Okay. And now we have 3 ratios. Perhaps let's just box up the ratios that we intend to use from now. So which is the one that we want to focus on? We focus on this, yeah. And with regards to the second, the ratio, do we focus on the one on top or the one below?
The one below.
The one below, okay. All right. So let's see where we can bring in the 42 kg now. Neighbors gave them 42 kg of newspapers each. How can we assign a value to it, assign a unit to it? If they receive 42 kg, means that from the before to the after, there should be an increase in units. So let's take Mark for example. Mark started out with 1 unit and he ended with 4 units. So that will be an increase of 3 units. These 3 units must be 42 kg. Okay. We could do a check as well for Ali. So Ali started out with 3 units and he ended with 6 units. Can you see that it is also an increase of 3 units? Okay, so this would be a check that, yeah, indeed 42 is 3U. So if 3U is 42, we should be able to find 1U. So 1U will be 42 divided by 3. Okay, and coming back to the question, how many kg of newspapers did both of them collect all together in the end? So what's the question asking you to find? In the end means we don't look at the before ratio, we look at the after ratio.
6 plus 4.
6 plus 4, so we look at this, that's right. So we have 140 as the answer. Don't forget to put in your kilograms. Okay, so I'll give you some time to jot down the solution before we move on to the next one. Okay, let's move on to the next question. Question 3. So this is taken from CHIJ. So next, Reese made some candles and pins for sale. 38 of the items made were candles. She sold 2/9 of the candles and 84 pins. In the end, she had 5/12 of the items left. How many pins did Reese make at first? Any word that stands out to you? And what do you think the concept is being tested?
Three, 8.
What else stands out for this question? We have candles and pins, right? Colleagues, any thoughts? Or Anna?
29, 84, 512.
Okay. Oh, so none of the words seem to stand out. So what concept do you think they are trying to test you based on these? Or would this be a question you consider skipping? kind of hard to identify, isn't it? Yeah. But you realize one thing about this question is that there are a lot of fractions. You might want to consider drawing it out. So sometimes when the question is presented to you and you find that information is all over the place, you cannot piece them together, the best is to start off with model. Okay, and perhaps from there it could lead on to something. Perhaps, I won't say it will definitely do, but it could. So let's see, 3/8 of the items made were candles. Do you think we could draw something? Yeah, with this information? I think we can. So perhaps let's start off with model method. So if 3/8 of the items were candles, then we would expect how many units to be made up of pins?
5 units.
5 units. Okay, so I'm going to draw a long bar with 8 units. And from there, 3 units would be candles. The rest would be pins. You see, when we have drawn this model, you realize you don't need to refer to the first 2 sentences anymore, right? So that kind of takes a load off our mind in terms of information overload. Now, next, we take a look at 2/9. She sold 2/9 of the candles. Do you think we are able to represent this on the model? Candles take up 3 units. So how do we find 2/9 out of these 3 big units? Any idea? From 3 units, can we change it to 9? Can, right? Yeah. We could split up one small unit into 3 smaller, split up one big unit into 3 smaller units, isn't it? So once we do so, let's split it up. And now you realize that we have 9 smaller units. So out of the 9 smaller units, 2 units were sold. So I'm going to put down S for sold. And we have 7 units left for candles unsold. Now, what do you think we could do to the other units that are not broken down? Do you think we would split it in the same manner?
Yes.
Yes, right? Okay, so let's do so for every big unit under pins. We are going to split it into 3 smaller units. So back to the question, we are done with this. 84 pins. Wow, okay, looks like we cannot even tell how many units 84 pin relates to. Let's leave the 84 pins aside first. And let's focus on the next piece of information. She had 512 of the items left. If she had 512 of the items left, that means we actually do have a clue from this fraction. The 12 here tells you the total number of units from start to end. If you were to count the total number of units, how many units could you find? If I were to count every small unit, you realize that it's actually 24. So if 5 out of 12 of the items are left, can we convert this 5 out of 12 into something out of 24? We are looking at equivalent fractions here, right? So from 12 to 24, you realize that we multiply it by 2. And we do the same for 5. 3 times 2. So our numerator becomes 10. Anyone lost at this point? Okay, all right. So if 10 out of 24 parts are left, why not let's pick out the parts that are left? Okay, so Under candles, we know 2 units are sold. So this is left 1, 2, 3, 4, 5, 6, 7. Okay, I'm moving on to pins already. 8, 9, 10. This portion of pins, nothing is labeled. But what do you think is the description for this group of pins? If they are not left, they have to be sold. So you can see that whatever that is not shaded here are the number of pins that are sold. Okay, and if we relate back to the question says 84 pins sold. So can we tell how many units 84 pins is now? We can. Okay, so if we were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 units here refers to 84. Wow, is 1 unit a whole number? Yes, right? Thankfully. Okay, so 1U will be 84 divided by 12. Divided by 12, we get 7. So how many pins did we make at first? Okay, so how do you think we can get that answer? How do we find the number of pins she made at first? So we are looking at this portion here. What was sold and what was left. So in terms of units, if we were to count, we have 15 units. So if 1U is 7, 15U would be 15 multiplied by 7. So we have 105 pins. This question is solved using model method. Yeah, so I'm giving you some time now to jot down the solution.
Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Do we move on to the next question? Anyone still jotting down the solutions? Okay, all right, we'll move on to the next one. Next two questions. Oh, okay, sorry. Still writing, is it? Okay, done already. All right, so we'll move on. Okay, this is a really lengthy question. Okay, let's take a look at it. From Catholic High, last year's prelims, Mrs. Lim prepared 160 chicken wings and some nuggets for a party. At one point during the party, an equal number of chicken wings and nuggets were eaten. So this should ring a bell already. 25% of the chicken wings and 20% of the nuggets were left. She then increased the number of chicken wings. After that, there was a total of 65 chicken wings. How many nuggets did Mrs. Lim prepare for the party? What was the percentage increase in the number of chicken wings after the same number of chicken wings and nuggets were eaten? So this is a 5-mark question. Oh, Okay. How do you think we can approach this question? So much of information. I think what stands out to us most would be equal number of chicken wings and nuggets were eaten. Yeah. Okay, so I'll probably underline this. So equal number, and then following that, you have the percentages left, right? So what concept do you think can be linked to this? We covered this on the first day. Equal what? Equal fractions. Yes. Okay, this is with regards to equal fractions. And of course, as we read on, you realize that the numbers seem to change. So it's just the first part of the question that we need to use equal fractions. And after that, we will have to consider something else. It may be a particular concept, it might not be. We see how it goes. Okay, so I will start off with equal fractions. Okay, so how could we put down the equal fractions? Let's consider that equal number of chicken wings, nuggets were eaten. So if 25% of chicken wings were left, what is the percentage that was eaten? 75%, right? Because we take a total of 100% minus 25%. So 75%, so 75 out of 100 parts of chicken wings must be equals to what other fraction of nuggets?
80%.
80%, so 80 out of 100 nuggets. Okay, so I'll use CW and NG for chicken wings and nuggets. You know how to do this, right? How to find the respective units for each. So if you can recall from the first day, our numerators must be the same. And you see, wow, the numbers are so big. Is there a way to reduce the numbers first so that maybe we can find smaller units? So perhaps 75 out of 100 could be reduced to 3/4. Yeah, bring down to simplest form. Use your calculator to help you. 80 out of 100 would be 4 out of 5. NG. Okay, now this looks more manageable. Looking at just the numerator, what would be a common multiple? So with 3 and 4, our common multiple is 12. Okay, so it will be 12 out of 16 parts of chicken wings equals to 12 out of 15 parts of nuggets. Can anyone tell me how many units of chicken wings are there and how many units of nuggets are there?
$16 units of chicken wing and 15 units of.
Okay, thanks, Alexa. And could we bring in the 160 chicken wings? Where do you think it fits in? Mrs. Lim prepared 160 chicken wings and some nuggets for a party. So the 160 just refers to chicken wings alone. So 16U is 160. We can find 1U from here. Which is 10. Now, after we found what 1U is, let's come back to the question. How many nuggets did Mrs. Lim prepare for the party? So where do we get our information from to get number of nuggets prepared? Just now, Alexa did mention this. Yeah, that for nuggets, it's 15 units. So if we know what 1 unit is, we could find 15 units, and that will be the number of nuggets. So we have 150 nuggets for the party. That will be our first 3 marks. It's not easy because there's so much of information. You need to know where to get the appropriate information from the question.
Wait, can
Okay.
you also take 160 times 3/4, then
100.
times 100 over 80?
160 times 3/4. Okay, why would you say multiplied by 3/4?
Because the equal number of the nuggets and chicken wings eaten, and then you can take that times 100 over 80.
100. Okay, so that means you want to find the number of chicken wings eaten first, is it?
Yeah, so you can find 80 units of the nuggets.
Okay, you can go by that way as well. That means you would prefer not to work with units, but you want to work with the actual number. Can. Yeah, so colleagues, if you have this intention, why not after the session, you try using your method and you compare your answers later with mine. Okay, you should be able to end up with the correct answer, but at least you earn another way of doing it. Yeah. Okay, let's move on to the next question. What was the percentage increase? So now we have to make use of information from the second portion of the question. She then increased the number of chicken wings. Okay, so looks like we need to delve into the number of chicken wings eaten and nuggets eaten, right? So how could we find out the number of chicken wings that were eaten? Could we find out from the number of nuggets eaten first? So if there are 150 nuggets, okay, and 20% of the nuggets were left, we could find the nuggets eaten. Just now, colleagues mentioned 80% of the nuggets were eaten. So that will be 80 out of 100 multiplied by 150. So in terms of nuggets eaten, will be 150. This is also the number of chicken wings eaten. So this clue is really important. Okay, because an equal number of chicken wings and nuggets were eaten. Okay, so far? Okay. So okay, if 120 chicken wings were eaten, okay, and it was mentioned that in the question, it was also mentioned that there was a total of 65 chicken wings in the end. So how do we reconcile this information? At first, there were 160 chicken wings. After 120 chicken wings were eaten, how many chicken wings were left? So let's focus on chicken wings. Chicken wings at first. Okay, we get the information from the first sentence, 160. Chicken wings in the end, we are not so sure. Chicken wings eaten, we have 120. Can we find the number of chicken wings in the end based on this? We take 160 minus 120. We will find how much was left. That was 40. So at the end of the party, there were 40 chicken wings left and 65, and the number was increased to 65, right? So what was the increase from 40 to 65?
$25.
So we take 65 minus 40, we get 25. Okay, so now that we have the increase in the number of chicken wings, we should be able to find the percentage increase in the number of chicken wings. So the percentage increase would be the increase itself over the original number left, which is 40, multiplied by 100%. So the answer will be 62.5%. That's for B. This question can be quite confusing. Alexa, you are done with the copying already. Oh, okay, that's fast. Can take a look at the last question. Okay, shall we move on to the next one? Okay, let's take a look at the next question. So here, an equal number of children attended Camp A and Camp B. Ratio of the number of girls to the number of boys in Camp A was 5:9. Ratio of the number of girls to boys in Camp B was 4:1. So altogether, there were 132 more girls than boys. How many children were there in both camps? 4-mark question from Losai School. Okay, so any clues that the question has given you on how to solve it?
Camp A is 5 to 9.
Okay. So we have what else? probably the other ratio as well, right? 4:1. Okay, and any more? Altogether, 132 more girls than boys. All right. Any more? One more piece of important information. First sentence.
Equal number of children.
Equal. Yes, equal number. There was a similar question that we did, right? Yeah, I think it was yesterday. Okay, so what concept do you think they're trying to test you?
Total unchanged.
Total unchanged. Okay, so let's try to solve this. But perhaps it may be a bit confusing to see so many numbers. So for the benefit of us looking at it more visually, I'm going to draw out in terms of models. Okay, so same, I'll be using total unchanged, but let me just draw out under Camp A and Camp B. So Camp A, the ratio of girls to boys is 5:9. So we have G, B, 5 units for girls. And for D, it's 9. I'll put down 5U, 9U. Okay, what can we say about B? We have ratio 4:1. And do you think the units are of the same size or different size? Probably different, right? Okay, because the ratios are different, so the number of parts are also different. So instead of putting it in units, I'll be putting it in parts. Okay. How do we move on from here?
Add up the total.
Add up the total. Okay, so let's look at the clue. What can we figure out from the clue first? What do you mean by total?
Like you add up Camp A number of girls and boys in total, then Camp B add up total.
Yes, because of the first sentence, right? Equal number of children attended Camp A and Camp B. So from Camp A, this is actually 14 units. And from Camp B, we have 5 units. Agree? Yeah. So from the first sentence, because both camps have the same number of children attending, we can say that 14 units is actually equals to, instead of 5, it should be 5P, equals to 5 parts. Okay. Now, let me just change this into finding 1U. Instead of 14U equals to 5P, could we find the value of what 1 unit is? So how do we find what 1 unit is? From 14 units to 1, we have to divide 14 by 14. And on the right-hand side, we divide 5 parts by 14 itself. So what is 5 divided by 14? Don't get a very nice number. It's fine. We'll write it as a fraction. So it'll be 5 out of 14p. Okay, so this is derived from the first sentence. Okay, what other things could we derive out of the other clues given? Note that altogether there were 132 more girls than boys. Could we compare girls versus boys? So if we count the number of units and parts for girls, okay, that would be 5 units plus 4 parts, right? So this would be girls. And if we were to compare it to boys, you have 9 units and 1 part. Now, if I were to add 132, to the number of boys, they will be equal. Yeah, because boys is lacking by 132. So if I add 132 to the number of boys, both boys and girls will balance out in number. Okay, so this will be for girls. This will be for boys. Boys will be this portion. Okay. Then the 132 is the extra, how much it's lacking in. Okay, so how could we go about solving this now? This is the second piece of information. Perhaps let me remove all the brackets to make it a little more simplified. So we have 5u plus 4p on the left-hand side. And on the right-hand side, we have 9u plus 1p plus 132. Okay, now we have to try to find either u or p. So let's try to bring in what we had earlier on. Earlier on, we found out that 1 unit is actually 5 out of 14 parts. Why not? Let's replace 1 unit, the 5 units here, by 5 times of 5 out of 14 parts. Okay, so every time I see a u, I'm going to replace it with 5 out of 14p. Okay, so 5u would be 5 multiplied by 5 out of 14p plus 14 plus 4p. Okay, this is on my left-hand side. On my right-hand side, I have 9u. 9u means 9 times of 5 out of 14p plus 1p plus 132. So you realize something, my u is no longer there. I have taken away u and replaced it with p. So 5u replaced with 5 times 5 over 14p. The 9u here, I replace it with 9 times 5 over 14p. Okay. Now let's simplify. Let's simplify what we have using calculator. So what is 5 times 5 out of 14? So if we were to multiply it, 5 multiplied by 5 out of 14, we will end up with 25 out of 14p plus 4p. Okay, and on the right-hand side, we would have 9 times 5. So that would make 45 out of 14p plus 1p plus 132. Okay, so everything is in terms of p now.
I guess.
Okay. So from here, we could simplify further. Why not let's add the p's up? Okay. So 25 out of 14 plus 4. Okay, that would give us 81 out of
昨天要补习啊？昨天补习啊？昨天补习啊？他来这边补。
Okay. And then 45 out of 14 plus 9. Okay. So if I were to take away 59 out of 14 from both sides, I will have 11 out of 7p equals to 132. Okay, and my p would be, to find p, I will have to divide both sides by 11 out of 7. And I will have 132 divided by 11 out of 7. I will get 84. So one part is actually 84. Now let's find the number of children in both camps now. We should be able to solve it. if we can find out what 1P is, yeah, 1P, we can find the total number of children attending Camp B. Agree? So Camp B has got 5 parts of children. If 1P is 84, 5P would be 5 times of 84. So that will give us 420. We also know that A and B have got the same number of children attending the camp. So wouldn't A be made up of 420 children as well? So the total number of children would be twice of 420. So we have 840. Okay, quite lengthy. Okay. Yeah. So I'm going to give you some time to put down the solution, and we might need to have a shorter break so that we could continue with the next part. Yeah, perhaps now it's time 10:17. Perhaps around 10:21 we could come back. So I will pause at this page here for you to take down the solutions, and we will continue at 10:21. Welcome back, everyone, from the short break. Let's now take a look at out of place questions. So out of place questions are questions that we want to really focus on. Take some time to see how sometimes certain questions can really throw us, out of our normal routine and familiarity, and how we want to cope with them. Okay, so I have 3 questions over here. Let's take a look at them. So this is taken also from SCGS last year's prelim, and it's a 4-mark question. Mrs. Salim spent $88.40 on some files and notebooks. She spent $18.40 more on files than notebooks. She bought 37 as many files as notebooks. Each file costs $3.20 more than a notebook. How much does each file cost? So you realize that it's kind of hard to associate this with any of the more common concepts that we have covered so far. But was there anything that come to mind that you might want to start off this question with? Well, probably we might want to focus on the values. Yeah, we have values given in dollars here. Okay, so we have $88.40 on some files and notebooks. So there are 2 items here, files and notebooks. Okay, now she spent $18.40 more on files. Okay, so we have an idea between files and notebooks. Files more expensive by $18.40. And maybe we can draw a model, right? Okay, if we don't want to draw a model, never mind, we can use units. So with this, perhaps we could come up with something like files, notebooks, all in all, $88.40. Okay, so this would be the first sentence. Second sentence, $18.40 more on files than notebooks, which means actually notebook, we could assign it as 1 unit in terms of cost, and file will be 1 unit plus $18.40. Okay, so from here, we could actually find the total cost spent on files. We could find the total cost spent on notebooks. Sometimes when we are so lost, we just do whatever we can to find a bit more information, and this could get us started. Okay, so let's not look at the other parts of the question first. We solve this part. At least we know how much do all the files cost and how much do all the notebooks cost. So can anyone tell me, how do we find the total cost of the files and the notebooks? We could find 2 units, right? Yeah. So 2 units would be $88.40. Take away $18.40. Okay. And here will be $70. From there, we can find what 1 unit is. So 70 divided by 2, we get 35. So this is the cost of all the notebooks. Okay, instead of cost of N, I'm going to put down cost of all the notebooks, $35. How about cost of all the files? We will have to add $18.40 to it. So if we were to add $18.40 to it, we will get $53.40. Okay, so far so good. So perhaps from here, we could get 1 or perhaps even 2 marks instead of 0. Let's move on to the next part of the question. She bought 37 as many files as notebooks. So we can see that, okay, she bought files and notebooks, but not equal in terms of number. She bought 3 units of files. She bought 7 units of notebooks. So this is actually 3 units worth and 7 units worth. Okay. So we pause here. Let's not move on to the next part yet. If the cost of 3 units of she bought 7 as many files as notebooks. So files is, files is actually 3 units. Yeah, the other way around. Okay, and notebooks is actually 3 units. So this is 7 and this is 3. Okay, so from here, could we find the amount of money spent on 1 unit of notebook? So if the cost of 7 units of notebook is $35, so the cost of 1 unit of notebooks would mean we take $35, divide by 7, and that would be $5. Similarly, we could also find the cost of 1 unit of files. We'll take 53.40, divide by 3. And that would give us 17. Yeah. So, okay, so now we have found 1 unit cost of notebook, 1 unit cost of files. Done with the next sentence. Now let's take a look at the last sentence that gives us information. Each file costs $3.20 more than a notebook. So it looks like we need to do a comparison between the cost of the file, one file, and the cost of one notebook. So if one file is $3.20 more expensive than the notebook, okay, and if we were to compare in terms of 1 unit, a group of files costing $17.80 and a group of notebooks costing $5. Now, how much is this difference then in terms of 1 unit of files and 1 unit of notebooks? So we take $17.80, subtract 5, we get $12.80. This $12.80 is the difference between a question mark number of files and notebooks. So if the difference between the cost of one file and notebook is $3.20, so you might want to ask yourself, how many times of $3.20 makes up $12.80? So how can we find that number? One way is by just adding on, right? To see how many times of 320 gives you 1280. Another way is to take 1280, divide by $3.20. Okay, so that will give us the number of items in 1 unit, whether it's number of files or number of notebooks. And we will have a nice number, which should be the case. Okay, so we have 4 items in 1 unit. So far, so good. Yeah. Now, question next asks, how much does each file cost? So let's see. In 1 unit of files, okay, I'm circling this part because this is the cost of 1 unit of files. And we know that in 1 unit of files, there are 4 files. So let's piece this information together. 4 files cost $17.80. Now we can find the cost of 1 file. So we take $17.80 divided by 4. So this is the answer. Give you about 2 minutes to jot down the solution. Then we'll move on to the next one. How do you all find this question?
A little difficult.
Yeah. It's common. And the thing is, when we come across questions like that, we don't panic. We always fall back on what we are familiar with. So that's why I wanted to stop at the second sentence. We find what we can first, then we move on. And the better we are at handling this, okay, the unknown, the uncertain, the more confident we will be, even when we don't know what the final answer is. So we allow the familiarity of previous topics or things that we know to lead us on. Yeah. It will definitely be one of the topics you have covered before. It's just that sometimes we need to be creative. Okay, we'll move on to the next one. This one may be a little more manageable. There are 3 types of flowers in a garden. There were 352 stalks of orchids. The ratio of the number of stalks of tulips to the number of stalks of lilies is 5:3. So we can see here from just these sentences what the different types of flowers are. The total number of stalks of tulips and lilies was 56% of all the flowers. How many more stalks of orchids were there than tulips? Okay, too much information. Let's break them down. So we look at what we want to focus on. We have 3 types of flowers. Okay, we don't need to underline 3 types of flowers, right? Because we could just look at the actual names. We have orchids, we have tulips, and we have lilies. Okay, what else is important here? 352 stalks, right? Orchids. Okay. What else? We have ratio of tulips to lilies being 5:3. And we have total number of stalks of tulips and lilies being 56% of all the flowers. Okay. I think what's important here is whether we can find out what our 1 unit is or what our 1% is. And from there, we should be able to find out any question that is going to be asked of us. So how can we find something based on all these that are given to us? If you find that underlining just the keywords and the clues is still confusing, we could put them down. We put them down in words. So sometimes it's clearer. Orchids. So we have 352 stalks. Okay. Tulips to lilies. So we have T to L. That would be 5:3. This is more relaxing for the eyes, right, and the brain. Okay, the total number of stalks of tulips and lilies was 56% of all the flowers. So again, tulips plus lilies would make up 56% of the flowers. Could we derive anything from the information given? if 56% is made up of tulips and lilies, can we find the percentage made up by the orchids?
44%.
How do you get that?
100% minus 56.
Okay, great. So that will be our first step. Minus 56. How else can we move on from here? Notice the word, okay, this color is very light. Orchids repeats itself twice over. Could we link these two pieces of information together?
44% equals to 352.
Okay, so from here, we want to find the number, come back to the question, how many more stalks of orchids were there than tulip? Orchids, we already know what number that is already, right? Can we find number of tulips then? How do we get to tulips?
Find 56%.
Okay, because we want to come back to this part, tulips plus lilies, right? So if 44% is 352, we could find 1% and subsequently 56%. So 1% would be to take 352 divided by 44. That would give us 8. And 56%, 56 times of 8, that would give us 448. Any of you are well versed in skipping from 44% to 56% in just one step? No, you prefer to have that 1%? So an alternative way, right, that you can do to skip from just one to the other step would be to take 300 and we combine the steps, okay? We, instead of dividing by 44, we change it into a fraction out of 44 times 56. Okay, because here in paper 2, we have the benefit of using calculator. So why not we input just one step into the calculator and straight away we will get our 448. Okay, so it depends on your level of comfort. If you find that you would still want to find that 1%, you get a number there, that's also fine. Yeah, I'm just introducing you an alternative method. All right, so now we have 448 tulips and lilies. Can we find number of tulips? We realize we haven't used this one, right? Eight units. Yeah, if we add up the units here, it's 5 plus 3. So 8 units would be 448. We could find 1 unit. So 448 divided by 8, we will have 56. And to find the number of tulips, multiply it by tulips is the first quantity, so we multiply it by 5. So we have 280. Okay, looks like we have all that we need to gather to get the answer. How many more stalks of orchids were there than tulips? So let's find the difference. So 72 is the answer. This is a lot more manageable than the previous question. Yeah. Okay, shall we move on to the next question? Anyone still copying? Okay, I'll hold on a while. All right, we'll move on to the final question. So this is a 4-mark question from ACS, last year's prelim. Hansel and Sherman had some blue and green stickers. So 3/5 of Hansel stickers were blue, while 2/3 of Sherman stickers were blue. Straight away, maybe what come across your minds? 2 of them have got different number of stickers. And not just that, the proportions are different. Okay, so if the proportions and the total number is different, we cannot associate their units as being equal. Next, Hansel gave 3/4 of his blue stickers to Sherman, and in the end, 7 out of 10 of Sherman's stickers were blue, and Hansel had 165 stickers left. Oh, okay, so now they are going to do a transfer, internal transfer, and there's a value given at the end. How many blue stickers did Hansel give Sherman, and how many stickers did Sherman have in the end? Anything that comes to mind when you look at this question here? What would you highlight out?
3/5 of Hansel's stickers were blue.
Okay. So if 3/5 of Hansel stickers were blue, can we also find the fraction of Hansel's stickers that were green? Because it's blue and green stickers, that means the remaining is green, right? We could say that 2/5 are green for Hansel. Okay. And the next portion, 2/3 of Sherman's stickers were blue. Here we could also tell that the remaining 1/3 is actually green. So this is information not given to you, but it's indirectly given. What else? Hansel gave 3/4 of his blue stickers to Sherman. So a lot of fractions in this question. Okay. Okay, 7/10 of Sherman's stickers were blue. Hansel, 165 stickers left. So how are we going to piece them all together? Could we start out by units? Or would we want to actually see what 3/5 is like, what 2/3 is like? Would we prefer to draw out in a model form? Maybe visually might work out better. Okay, so we might want to start by drawing it out, and we see if there's anything that clicks, anything that we can connect to what we already know, what is familiar to us. Let's start out by drawing out what Hansel has. So if 3/5 of Hansel's stickers were blue, okay, we can draw out how many units? 3/5, the 5 in the denominator gives you the total number of units. So I'm going to draw out 5 units. And I'm going to mark out blue. outside. Okay, you might be wondering, how come I don't want to put the letter B in there? Why do you think I actually mark out blue on the outside? Any idea? Now, I marked out blue on the outside because later Hansel is going to give some to Sherman, right? And if he's going to give some stickers to Sherman, which means I might need to cut my 3 units of blue into smaller parts. So I don't want the B, right, to look like half here, half there. I put the blue outside instead. Okay? Yeah. So if you are not sure whether, in the actual exam to write the numbers outside or inside, it's okay. If you write it wrongly inside, never mind. Don't use pen to draw, use pencil. There's always something called eraser. You can erase it off. Yeah. But if you use pen, it may be a bit more difficult to get it erased. Okay, let's consider Sherman now. So 2/3 of Sherman's stickers were blue. All in all, Sherman has got 3 units of stickers. I'm going to draw 3 units. And just take note that the units are all of different sizes. 2/3 blue. So this means that the remaining 1/3 will be green. Okay. First 2 sentences done. Hansel gave 3/4 of his blue stickers to Sherman. So let's take a look at Hansel's stickers that are blue. So we are looking at this. If it is 3/4, then how are we going to divide it into 4 parts now? Right, so instead of 3, how can we subdivide such that this number here can be quartered? So let's think in terms of 3 times table, because we're looking at 3 parts, right? When we list out the 3 times table, is there a particular number that can be divided by 4 very nicely? Well, okay. So 3 can be split further into 12, which means that one big unit of red is split into 4 smaller parts. Now we have 12. So we could easily find what 3/4 of blue stickers stand for. That's fine. 3/4 of the number of blue stickers, so times 12 units, that will give us 9 units. Okay, so I'm going to take out 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this would be given to Sherman. Okay, I'll just put S for Sherman, no space. What do we do with the other 2 green big units? Do we also divide them into 4 smaller units each? We do, okay, so I'm also going to subdivide them. Okay, so what have we? Under green, we have 8 units here. Under blue, we have got 12 units. Okay. Okay, so what else can we make use of? We have made use of the third sentence. In the end, 7/10 of Sherman's stickers were blue, and Hansel had 165 stickers there. We have done so much with Hansel and the units there, right? We know that Hansel had 165 stickers there. Could we match this to the number of stickers that are not, the number of units that are not shaded. So let's see, how many units does Hansel have left? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the number of stickers left. So 11U must be 165. So if 11U is 165, we could find our 1U, 165 divided by 11. That gives us 15. Now, how many blue stickers did Hansel give Sherman? So let's come back to the model. The shaded parts, the blocked out parts are the ones given. So 9 units were given. If 1 unit is 15, 9 units will be 9 times of 15. So that would give 135. So the answer for A is 135. Okay, so far? Now, we'll move on to the second part of the question. Then I'll give you some time to copy the solutions. How many stickers did Sherman have in the end? Okay, looks like we have used up pretty much every piece of information except the 7 out of 10. How do we bring in 7 out of 10? 7 out of 10 of Sherman's stickers were blue. Okay. So this is when the 9 units from Hansel went over. But it's kind of hard to put the 9 units into what Sherman has because the units are different sizes. Why not? Let's look at this part in another angle. Now, if 7 out of 10 of Sherman's stickers were blue in the end, so in the end, how many units of green stickers does he have? Okay, 7 out of 10 units are blue. Therefore, green is 3 because that's the remainder. So it looks like we could do something to the green stickers here. Instead of 1 big unit, I need to split this up into 3 small units. So this is 3 out of 10. Yeah. If this is 3 out of 10 and Sherman didn't touch his blue stickers in the first place, this would be another 3 out of 10. Okay, so let me just put this one down. This is 3 out of 10 of his stickers. This portion here is 3 out of 10 of his stickers. This portion here is another 3 out of 10 of his stickers. So 3, 6, 9, 8, where's that missing 1 out of 10? The missing 1 out of 10 of the stickers is what Hansel gave him. Okay, so the 1 out of 10 of the stickers that Sherman has in the end is what Hansel gave him. So how much did Hansel give to Sherman? Hansel gave 9 units, which is 135 stickers to Sherman. Hansel gave 135 stickers to Sherman. And now Sherman has got 10 units of stickers in the end. So if 1 unit is 135, could we find what 10 units is? That would be 10 times of 135. So he will end up with 1350 stickers. Oh, okay. So this is the solution for the last question. Give you some time to take down the solutions. Gwen, how do you find this question?
It's easier than the
Easier than the first
question.
one.
Yeah.
Okay. So if you come across questions like that, you think you're able to at least start with something?
Yeah.
Try. Yeah.
Sure.
I think one way to go is to consider model drawing. Yeah, because when we are able to picture it, it's a lot easier. And not sure whether you're aware that it's probably your last year that you can use model drawing. Move on to secondary school, there is no more such things. Yeah. So solving for problems will be more or less like 99% algebra based. Okay. So cherish your last few months of it. Okay. Anyone still writing down the solution? Okay. So hopefully you have found the 3 days of workshop helpful to you. And is there anything that one takeaway that you have from this session? Maybe just have a quick sharing. Anyone? Anyway, I do have a feedback form. You could scan the QR code over there and fill out the feedback form. And in one of the questions in the feedback form, perhaps let me just share it with you. Let me stop the share first. So let me bring you to the feedback form. Okay, so it looks something like that. There will be this part in the feedback form where they actually ask you, with regards to okay, topics of interest you would like to be covered for future workshops. You might want to consider sharing with me certain areas that you would like me to look into for future workshops, not just for this year, but understanding that next year you are moving on to Set 1. Would you be interested in something like a bridging class or something that is like term-like, maybe consolidate certain topics that you would like me to go through? Of course, we won't be going through all these things. It will be secondary 1 topics. Yeah, let me know so that I could get back to you as well. Yeah, so I hope that you've enjoyed the last few sessions, the last 3 sessions of the workshop. And yeah, do take care and hope to see you around again. Yeah, so thanks everyone for your time. All right, take care everyone. All the best for PSLE. Yeah? Bye-bye.